Beneath your very footsteps lies a world quietly humming with life and memory. Imagine the soil as the earth's gentle skin, soft yet strong, holding stories of rain, roots, and time itself. This first step into the depths beneath you reveals a place where particles of stone whisper ancient tales, and invisible communities dance in the darker, beginning to a journey that will stretch your imagination and soothe your mind too. Rest. When you stand still, close your eyes if you like, and think about the ground below your feet. You might imagine it as something solid and silent, just dirt, a stage for you to walk or rest. But imagine for a moment that the earth beneath is more like a vast, breathing book, each grain a tiny letter in a story that is never finished. The soil under your shoes is alive with history, a slow and gentle keeper of secrets that have been whispered for thousands, even millions of years. Picture soil as the soft skin that covers the planet's podia, delicate blanket that wraps over mountains, fields, and forests with both care and strength, though it feels simple when you brush your hand across it or let it crumble through your fingers. Soil is a marvelous blend of stories, life, and time. Its surface is just the top layer of a living tapestry woven by wind, water, roots, and creatures too small to see. The earth's skin is thin, just a few feet deep, before it touches the hard rock beneath. But within this slender space is a bustling underground city. In this city, billions of tiny creatures live and work continuously. Your soil neighbors are not mammals or birds, but creatures like bacteria, fungi, and microscopic animals whose lives interlace in an endless dance. These tiny helpers decompose fallen leaves and dead plants, turning them into nutrients that fuel new growth. They build web-like threads beneath the surface, connecting roots of faraway trees so that forests can share messages, water, and food. To begin understanding this living soil, imagine it as a soft garden made of mineral grains, broken bits of stone mingling with the remains of once living things. This mixture wasn't formed in an instant, it's the product of long, patient work by nature. Rocks wear down slowly under the touch of wind, rain, and the gentle pressure of plant roots. Like a sculptor polishing a statue, the forces of weathering turn solid stone into grains of sand and dust. Ready to cradle seeds and life, each handful of soil you hold contains a blend that took hundreds, sometimes thousands, of years to craft. It is a slow recipe, a sprinkling of sand and silt, a pinch of clay, and a mix of tiny decayed leaves and roots, all blending into a cradle for new plants to rise. Think of it like a layered cake, where each ingredient, each crumb, is essential to the flavor and texture. Without this careful balance, life above could not thrive. Sometimes soil feels dry and dusty, but even then, it remembers water. Water shapes the soil like an artist shaping clay, soaking it with life and carving its layers. Each drop that falls, whether a gentle rain or a rushing flood, leaves traces whispering how thirsty or drenched the land has been. Floods bring new minerals, while droughts leave salt crusts, a gentle reminder of the earth's quiet endurance. Like a diary, soil holds these records of waters, moods, patiently waiting for a curious mind to read them. If you dig gently into the earth, you might find it arranged in layers called horizons, the soil's own storybook pages. The top is dark and rich, full of life and decay, like the opening chapter brimming with promise. Deeper down, the colors fade, and minerals shift as you move closer to the ancient bedrock. At the very bottom, the parent material of all soil. Each layer speaks of changes. Some tell of ancient fires that swept through forests, their echoes preserved in blackened charcoal flakes. Others hold the pale ashes of volcanic skies long ago. Your soil is a layered memory, each band a testament to the passage of time and the cycles of nature. It quietly records the rise and fall of forests, the coming and going of animals, and even the footsteps of the people who have walked the land before you. Like a wise keeper, the soil remembers and protects these stories without ever needing words. Beyond minerals and stones, the earth holds a mysterious treasure seat. These tiny packages of life are tucked away, resting patiently beneath the surface in a state called dormancy. They are time travelers, waiting quietly for the perfect moment to awaken and bring vanished landscapes back to life. Some seeds have slept for hundreds, even thousands of years, preserving the memory of plants long gone. Imagine a single seed as a bookmark in a book of life, waiting for your touch, the right season, or a warming fire to turn the page. Similarly, the soil holds strands of life itself in the form of DNA, molecular, memories of creatures and plants that lived through ancient times. These tiny fragments in the dirt are like whispers of past eras, frozen and preserved beneath your very steps, carrying stories far older than our own. Through these traces, the Earth's diary becomes a living manuscript, one that future explorers and scientists can gently open to understand the vast history of life. The living communities in the soil also carry memory. Microbes respond to changes in their world, like old friends who remember how fires, floods, and farmers' plows have shaped the land. Some fungi can generate spores that survive great heat, waiting for fire to clear away the old, so new life can bloom. These underground networks are like an orchestra playing a quiet melody of resilience and rebirth that the surface world may never hear, but always feels. As you feel the earth beneath you, remember, it is both cradle and grave, ending and beginning. With every breath, the soil exchanges gases, breathing life into the atmosphere and receiving it back in turn. It acts as a sponge, soaking up rainfall and slowly releasing water that nurtures roots and rivers. The earthy scent that rises after rain is a quiet memory, a perfume created by tiny bacteria deep underground, a gentle whisper reminding you of the unseen life all around. In this quiet world beneath your feet, science and poetry meet. The soil is at once a guardian of ancient secrets and a hopeful guardian of the future. It invites you to slow down, to listen to its calm stories, and to feel connected to a vast rhythm, the slow pulse of the planet. As you rest tonight and drift towards sleep, imagine your body becoming as still as the earth. Let your mind gently wander through the soil's layered stories, a book of ancient days, a living tapestry woven of dust, roots, fire, and rain. Know that beneath you is a world alive with memory, holding your place in the great unfolding journey of life. And now, as your eyes grow heavy and your breath slows, let the soil's quiet patience carry you softly toward dreams. What stories will the earth gently reveal to you next? When you listen again, the journey has only just begun. Beneath your feet lives a bustling city unseen, where tiny creatures weave webs of life and memory. The soil's invisible communities are gardeners, builders, and messengers, silently shaping the world above. As you imagine this hidden metropolis, allow your mind to slowly wander through the quiet magic that makes soil alive, a gentle lullaby of life beneath the surface, steady and enduring. Close your eyes again and imagine holding a single teaspoon of healthy soil, just a tiny scoop taken from a meadow or a garden. To your naked eye, it might look like nothing more than ordinary dirt, a handful of brown dust, but inside that small spoonful lives a world more crowded, more complex, and more alive than a bustling city street. This invisible city teems with billions of inhabitants, creatures so small you cannot see them without a powerful microscope. These tiny life forms include bacteria, fungi, archaea, and countless other microorganisms. Together, they form a living web, a community that tirelessly works beneath the ground, weaving connections deeper and broader than any human city could ever dream. Imagine bacteria as the hard-working neighbors, breaking down fallen leaves, decayed wood, and dead animals into tiny pieces. They are nature's recyclers, transforming what once lived into rich nutrients that plants greet like a welcome breakfast. Some bacteria even have a magical skill. They draw nitrogen from the air, a gas invisible to you and me, and change it into forms that plants can use to grow strong and tall. They are the quiet chefs of the soil kitchen. And then there are the fungi, weaving thin, silky threads that spread far and wide. These fungal strands, called mycelium, move like underground highways, connecting the roots of different plants across forests and fields. Think of this as a silent internet beneath your feet, where trees talk, share nutrients, and even warn each other of danger. When one tree suffers drought or disease, its fungal friends quickly pass along messages, helping others prepare. In this way, the soil becomes a cooperative community, not just a place of survival, but of connection and mutual care. These microbes do not live in chaos, but in tiny neighborhoods, where mineral grains and organic matter cluster together like city blocks. These clusters create pore small spaces where air can flow gently, water can trickle slowly, and roots can breathe deeply. Good soil is not compacted or tight. It has just the right balance of solid bits and open space, like a well-planned town with parks, streets, and homes for its citizens. Not all soils are the same. Some are sandy and drain water quickly, leaving thirsty plants behind, Others, heavy with clay, hold on tightly to water but can suffocate roots if too dense. The best soils, called loam, blend sand, silt, and clay with rich organic matter to provide a perfect home for life to flourish. This harmony beneath your feet supports the flowers, grasses, and vast forests you see above. Now, imagine this microcosm as a living memory book, where each microorganism carries secrets of past fires, floods, and seasons. When a wildfire roars through, it seems to destroy everything. But many fungi have heat-resistant spores that survive, waiting patiently for new life to begin. These fungal spores are like seeds of hope, prepared to spring into action when the soil cools. Fire's memory lives on in their resilience, shaping how the land heals itself, chapter by chapter. Likewise, the soil's microbial communities remember farming and human disturbance. Years of plowing changed the balance of bacteria and fungi, leaving behind traces that persist long after fields are abandoned. When nature reclaims the land, the microbial memory influences which plants return first. Sometimes a forest regrowing is not the same as one that was never farmed. The soil remembers its human visitors, quietly carrying their stories in the shifts of microscopic life. The microbial memory also extends to pollution. Heavy metals and pesticides left by human activity are encoded into the soil's living record. Some bacteria evolve resistance to toxins, and fungi adapt to new chemicals. These adaptations linger long after the harmful chemicals have faded, telling a tale of survival and change under pressure. Scientists can read these clues to reconstruct the history of pollution and disturbance. Soil is a silent witness to our footprints, both gentle and heavy. But this memory is not only about scars or endurance. It is also about cooperation and community. The fungal networks that connect tree roots spread nutrients, water, and messages, shaping the growth of whole forests. In grasslands, microbes adjust to the presence of large grazing animals, specialized bacteria breaking down the nitrogen-rich waste left behind. Even centuries after herbivores have moved on, the soil remains primed for their return, as if waiting patiently to welcome back old friends. Waterlogged soils tell their own story. When rain fills the spaces between soil grains and oxygen grows scarce, certain microbes take over, shifting the underground chemistry and producing gases like methane and nitrous oxide. As the soil dries, a different caste of microbes reclaims the territory. These cycles, repeated over time, leave fingerprints in the microbial profiles, another layer of memory, shaped by the rhythms of wetness and dryness. Science even suggests that microbes can hold genetic memories, passing survival tricks across generations by sharing DNA. If a pathogen or pollutant once threatened a soil community, the genes that helped survive may persist long after the danger has passed. This is like a living library of past challenges, preparing the soil to face future ones. It's a memory that doesn't rest but actively helps the soil community endure and thrive. To think that a single gram of soil contains more bacterial cells than there are people on Earth is staggering. Alongside them live thousands of fungal species, together creating a genetic library far richer than the human genome. Many species remain unknown and unnamed, mysteries hidden in the soil's depths, waiting patiently for discovery. Scientists now explore how these microbial memories can help restore damaged lands. Introducing fear-adapted fungi into burnt landscapes can aid recovery. Nitrogen-fixing bacteria amplify fertility in exhausted farmland. In this way, the soil's memory is not just passive record, but an active partner in healing, a hope written in microbial code. There is a gentle irony in this unseen world. Microbes are some of the oldest life forms on our planet, yet are nearly invisible to us. They build no bones or shells to fossilize, but their living communities and genetic traces build memory into the soil itself. Without them, soil would lose not only its vitality, but its deep connection to the past. The soil's story would fracture, incomplete and disconnected from the rich history written in microbial life. Though the ground beneath us looks solid and stable, in the microscopic realm it is constantly shifting. Populations rise and fall, genes exchange and adapt, the community renewing itself like a never-ending melody. This dynamic flux is the soil's memory in motion, a memory not about freezing moments unchanged, but about holding just enough of the past to guide the present and shape the future. In this remarkable resilience lies comfort. While human memories fade and written records crumble, The soil remembers all, recorded not in words, but in living spores, resilient genes, and threads of fungal life stretching invisibly through the dark. The soil's living memory is a story of endurance, written not in ink, but in life itself. So the next time you see a forest regrow after fire or a field bloom after years of rest, remember this: the recovery you witness is not just the work of seeds in sunlight. Beneath the surface, armies of microbes have already prepared the stage, reaching into the soil's memory to guide renewal and growth. In these quiet, unseen ways, the soil's invisible city acts as the keeper of life's long story, ensuring that nature's tale continues no matter how often it is interrupted. Like a gentle guardian, it holds the past close and shapes the promise of tomorrow. Now, as you feel the slow heartbeat of this hidden world beneath you, allow your body to soften and relax. Imagine the soil's endless life gently cradling your feet, a quiet lullaby whispered in billions of breaths. What mysteries will the invisible city share with you next, as you drift deeper into peaceful slumber? Beneath your feet, soil is not just a uniform heap of earth, but a book written in layers. Each layer, called a horizon, is like a page in the land's history, telling different parts of an ancient story. These horizons reveal secrets about the environment, climate, plants, and even the actions of people who once lived there. The very top layer, the organic horizon, is rich with decomposed leaves, roots, and tiny creatures. It's often dark and crumbly, bustling with activity. This layer is sometimes called the litter layer because it looks like a blanket of fallen material. Here, decay breaks down old life, making nutrients available for new plants. Seeds sprout, roots dig down, and fungi thread through, all thriving in this freshest page of soil. Below this lies the A horizon, or topsoil. This is what most people think of as soil: dark, fertile, and full of life. It mixes minerals from the rock below with organic matter from above, forming a nurturing home for plants and microbes. This layer's quality often decides if crops will flourish or fail, and once it erodes, it takes centuries to rebuild. Entire civilizations have depended on the richness of this horizon. Deeper still is the E horizon, often pale and less fertile. Water moving downward leaches away minerals and nutrients here, carrying them away to lower layers. This leaching layer shows how water shapes the land by redistributing soil's riches, though not always present when it exists. It reveals stories of how water has moved through the terrain. Beneath that is the B horizon, or subsoil. Here, minerals and clay accumulate, creating bands of colors: yellows, reds, and browns from iron and other elements reacting to water and air. While it has less organic matter than the topsoil, the subsoil is crucial for storing nutrients and water, supporting plants with deeper roots. The C horizon marks the transition zone between soil and unaltered rock. It contains weathered fragments of bedrock just beginning to break down. It is less alive but is an important foundation that supplies minerals to the layers above. At the very bottom lies the R horizon, solid, unbroken bedrock. This parent rock slowly weathers over millennia, feeding the soil layers above and continuing the endless cycle of soil formation. These horizons together form a soil profile, a layered record spanning centuries or millennia. Soil scientists can read these pages to understand how the land was shaped, what plants grew there, and even what past climates were like. The colors and textures tell tales. Dark, rich layers mean plenty of organic life. Pale or bleached layers mean nutrients were leached away. Reds and yellows speak of iron oxidizing over time. Bluish hues often mark waterlogged soils lacking oxygen. Texture too is a storyteller. Sandy soils drain quickly but struggle to hold nutrients, while clay soils store water and minerals but can suffocate roots if too dense. Loam, a balanced mix, often offers the best conditions for plants. Soil horizons also preserve the memory of events. Charcoal layers mark ancient fires. Sand deposits reveal flood episodes. Ash layers speak of volcanic eruptions. Shifts in color or texture hint at farming, grazing, or other human activities long gone. Peeling back soil profiles is like traveling through time, revealing natural changes and human impacts intertwined. Yet, soil is fragile. The fertile top layers that sustain so much life can be lost in a single heavy storm if left unprotected. Recovery takes centuries. Understanding soil's layers is not just about science, it's also about appreciating something precious and irreplaceable beneath our feet. Around the world, No two soil profiles are exactly alike. Tropical regions with heavy rains often have thick but nutrient-poor soils due to leaching. Cold climates accumulate dark, organic-rich soils slowly. Grasslands build some of the richest topsoils from cycles of plant growth and decay. Each ecosystem writes its own version of the story, a unique layering that tells us about time's passage and life's endurance. Soil may look simple on the surface, but by reading its layers carefully, we discover deep narratives of Earth's past, of shining glaciers, quiet forests, blazing fires, flooding rivers, and human footsteps lost in time. Through these soils, Earth's diary invites us to pause, listen, and know the planet's memory beneath our feet. Beneath every field, meadow, and forest floor lies a secret archive more astonishing than fossils or charcoal, a vast collection of seeds. These tiny packages of life have fallen year after year, generation after generation, slipping quietly into the ground. Many never sprout immediately, but lie in a state of dormancy, suspended between past and future. This underground seed bank is one of soil's most remarkable memories, storing the potential of ecosystems long vanished and carrying them forward for centuries, sometimes even millennia. Seeds are designed for survival. Each one is a miniature time capsule containing an embryo and a store of nutrients protected by a tough coat. While some germinate quickly when conditions are favorable, many have evolved to wait patiently through years of drought, floods, fires, or grazing. They only awaken when light, temperature, and moisture align perfectly. This dormancy may seem wasteful, but it is a hedge against uncertainty, a way to spread risk across generations so that plants can persist even when surface conditions change dramatically. Soil seed banks vary widely in size and composition. A square meter of fertile meadow soil may contain tens of thousands of viable seeds, representing dozens or even hundreds of plant species. Forest soils usually hold fewer seeds but maintain reserves capable of regenerating vegetation after disturbance. Wetlands, deserts, and tundra all carry their own unique seed collections, adapted to the rhythms of each environment. In this way, the seed bank acts like a genetic library buried beneath our feet, available for ecosystems to draw upon in times of need. Some seeds possess lifespans that seem almost magical. For example, lotus seeds have been found viable after more than 1,000 years in dry lake beds. In Israel, a date palm seed recovered from a 2,000-year-old archaeological site was successfully germinated in the 21st century, producing living descendants of ancient trees. Arctic tundra soils have yielded seeds preserved in permafrost for tens of thousands of years, some coaxed back to life by scientists. Each case is a vivid reminder that soil is not just a graveyard for fallen plants, but a vault of possibilities holding on to life long after it was first scattered. Seed bank also preserves the memory of ecosystems that shifted or disappeared. In areas transformed by agriculture, patches of soil still contain seeds from the wild vegetation that once thrived there. Abandoned fields, for example, often burst into bloom as long-dormant native seeds find space and sunlight. In wetlands that were drained and later restored, seed banks provide the initial wave of recovery, bringing back species absent from the surface for generations. The soil remembers what once grew there and offers it back when conditions allow. Fire forms an important part of this story. Some seeds are adapted specifically to germinate after fire, with hard coats cracked by heat or dormancy, broken by smoke chemicals. In chaparral and savanna ecosystems, fires that seem devastating to the eye unlock the soil's hidden seed reserves, prompting explosions of wildflowers and shrubs. The flames clear the surface, but the soil's memory ensures that life returns, sometimes more vibrantly than before. Human history is also written into the seed bank. Archaeologists often analyze soil for preserved seeds to reveal what crops were grown and what wild plants surrounded ancient fields. Charred seeds from cooking fires can survive thousands of years, while seeds buried in abandoned soils reveal lost agricultural practices. Thus, the seed bank carries both ecological and cultural memories of human interaction with plants. Modern science has adopted this natural strategy on a grand scale. Global seed vaults, such as the Svalbard Global Seed Vault in Norway, store duplicates of the world's crops in cold, dry conditions. These collections serve as insurance policies for agriculture, preserving genetic diversity against disasters, diseases, or climate change. But nature's own seed banks have been burying and protecting biodiversity far longer, quietly maintaining life's continuity underground. The presence of seed banks complicates ecological restoration efforts. Invasive species can linger long after removal from the surface, waiting in the soil to sprout when conditions favor them. Managing landscapes therefore requires not only dealing with visible plants, but also addressing the hidden reservoir below. The soil's memory can sometimes work against human intentions, by offering back species we might rather forget. Despite such challenges, the persistence of seeds is one of nature's most hopeful features. In urban areas, cracked pavements and abandoned lots often sprout plants from seeds dormant beneath the ground. After landslides, floods, or volcanic eruptions, seed banks provide the first sparks of regrowth. The soil contains the instructions for recovery within its buried library. At a deeper level, the existence of seed banks reminds us of life's resilience. Plants do not rely on certainty. They cast their futures into the wind, water, and soil, knowing some seeds will fail, others will wait, and a few will seize the perfect moment to grow. Soil gathers these scattered chances, holding them safely until circumstances change. This memory is not fossil or isotope, but living potential. There is something quietly poetic in the thought that, beneath every step lie countless seeds silent but ready. A field may look empty under winter's frost, but seeds sleep in the soil. Some destined to rise in spring, others perhaps centuries later. The ground is never just what it seems. It is both present and future, a living archive of what has been and what may yet return. The soil seed bank is more than an ecological curiosity. It is a reminder of continuity, showing how life endures cycles of abundance and scarcity, disturbance and calm. It is the Earth's way of keeping options open, ensuring no single drought, fire, or flood can erase everything. As long as seeds remain buried, the memory of past ecosystems endures, ready to awaken. In the end, soil beneath us is not just a surface to walk on, it is a library of life in waiting. Seeds buried centuries ago may one day germinate, carrying the voices of lost landscapes back into the present. To appreciate the seed bank is to witness time at work in the ground, a patient storehouse of resilience and renewal. It is a memory both fragile and powerful, telling us that, even in the quietest, barest earth, the future lies just below the surface, waiting for its moment to grow. Soil is not only a repository of seeds and minerals, it is also alive with countless microorganisms that hold some of the soil's most powerful and dynamic memories. Billions of bacteria, fungi, archaea, and other tiny life forms teem within a handful of healthy soil. These microscopic communities are far from passive. They respond to changes, adapt to challenges, and in doing so, carry echoes of the past that shape the present and future of ecosystems. Take fire, for example. A wildfire may sweep across a forest, leaving ash and scorched earth in its wake. To the casual observer, it might seem that life below the flames has been destroyed. Yet soil microbes carry a hidden resilience. Certain fungi produce heat-resistant spores that survive temperatures lethal to most organisms. These spores lie dormant until fire clears away competitors, then burst to life, decomposing charred wood and kickstarting the ecosystem's recovery. In this way, microbes do not just remember fire, they prepare the land to heal in a specific sequence. In farm soils, the impacts of repeated plowing and planting become inscribed in microbial communities. Some bacterial groups thrive in disturbed conditions, while others decline. Over decades, these shifts become imprinted in the soil's living code. Even if farmland is abandoned, its microbial legacy often persists, influencing which plants return and how nutrients cycle. A forest regrown on old farmland differs from one always while the microbes ensure it. Microbial memory also records pollution. Heavy metals, pesticides, and fertilizers alter soil microbiomes, sometimes for centuries. Bacteria evolve resistance and fungi adapt to chemical changes. Scientists can detect these microbial fingerprints to reconstruct soil histories of stress. Soil becomes a witness, quietly recording what has been poured into it and how life beneath responded. This memory isn't only about scars, it also holds cooperation and continuity. Mycorrhizal fungi form networks linking tree roots across forests. These fungal threads transfer nutrients, water, and chemical signals, helping trees prepare for drought or recover from storm damage. Such networks carry the genetic and ecological memory of old forests into new ones even after surface changes. Similarly, microbial communities reflect the presence of grazing animals long after they leave, priming the soil for their return. Floods and droughts to imprint on microbes. Waterlogged soils become oxygen poor, favoring microbes that produce methane and nitrous oxide. Drying favors aerobic microbes. These cycles leave microbial fingerprints showing how often and how intensely soils faced extremes of wetness and dryness. Microbes also store genetic memory. Through horizontal gene transfer, bacteria share resistance traits across generations. If a soil once faced pollutants or pathogens, genes for surviving them may linger, making the soil more resilient when challenges recur. This is not conscious memory, but it functions similarly past conditions preparing for the future. The scale of this microbial archive is staggering. A single gram of healthy soil can host over 1 billion bacterial cells and thousands of fungal species, together representing a genetic library far larger than the human genome. Sequencing often uncovers countless unknown microbes, some potentially key to ecosystem resilience. Soil memory is thus still being written line by line in microbial code. Researchers explore how this microbial memory might aid restoration. Introducing specific fungi or bacteria into degraded soils can rekindle old ecological functions for adapted. Microbes can help restore burned landscapes, while nitrogen-fixing bacteria may jumpstart growth in exhausted farmlands. Memory is active, a tool guiding recovery if we learn to listen and apply it wisely. There is gentle irony here. Microbes are among Earth's oldest life forms, yet world's least visible. They do not fossilize bones or shells, but they build memories encoded in living communities and genetic adaptations. Without them, soil would lose vitality and continuity with the past. The soil's memory would fragment. The ground beneath us may seem stable, but microbial life is in constant flux. Populations rising and falling, genes exchanging, communities shifting. This dynamic balance is what allows soil to remember, not by preserving all unchanged, but by keeping enough of the past to guide the present. While human memories fade and written records crumble, soil remembers in ways that endure. Its stories are told not in words but in survival of spores, resilient genes, and fungal networks stretching through the dark. The memory of soil microbes is not stored in books or monuments, but in living resilience, a memory written not in ink, but in life itself. So next time you see a forest regenerate after fire, or a field bloom after farming, know the recovery is not just seeds and sunlight at work. Beneath the surface, armies of microbes have already prepared the stage, drawing on memories of disturbance and renewal. In their quiet, unseen way, they are keepers of soil's living history, ensuring the story of life continues, no matter how often interrupted. Fire has always played a dual role in shaping landscapes as both destroyer and creator. Watching flames sweep through forests or grasslands is witnessing transformation in its most dramatic form. Trees collapse, animals flee, and the scenery is remade within hours. Yet long after the smoke clears and embers cool, the memory of fire remains imprinted in the soil. Soil holds the traces of past fires in charcoal and ash, blackened fragments, and mineral-rich dust. These particles serve as quiet testimony to the heat that once roared above. Charcoal, surprisingly durable despite its fragile appearance, forms when plant material is heated without enough oxygen for full combustion. Instead of turning to ash and smoke, it carbonizes, producing dark, lightweight fragments that resist decay. Charcoal buried in soil can persist for thousands of years, with archaeologists frequently identifying it in earth profiles as markers of ancient fires. Ash, conversely, is the mineral residue of fully completed combustion, made up of calcium, potassium, magnesium, and other elements. Ash is lighter but more vulnerable to erosion. When ash settles into soils, it can alter their chemistry. Some ashes increase alkalinity, changing what plants can grow, while others provide sudden nutrient surges that fuel bursts of regrowth. Scientists analyze charcoal fragments in soils to reconstruct fire histories. Regular pulses indicate periodic wildfires sweeping predictable intervals, while gaps reveal periods of fire absence. These patterns reflect not only fire frequency, but also the adaptive responses of ecosystems. For example, Grasslands often show frequent charcoal layers that reflect their dependence on regular burning to maintain open fields, whereas forest soils may reveal less frequent but more intense fire events. Volcanic eruptions leave even more dramatic soil imprints. Volcanic ash layers, called tufa, blanket vast regions with minerals unique to each eruption, creating precise geological fingerprints. By matching these ash layers across wide areas, researchers trace eruptions, reach and date them accurately. For instance, the eruption of Mount Mazama, 7,600 years ago, which formed Crater Lake, Oregon, deposited ash across much of North America. Today, soil scientists recognize this pale layer when digging in the right regions of soil as an archive. Wildfires also chemically alter soils. Intense heat changes mineral structures, affects how clays hold water, and releases nutrients bound in organic matter. Post-fire soils frequently show elevated phosphorus and potassium levels, acting as natural fertilizers. These enrichments explain why many plants sprout vigorously after fires, and why some species have evolved to depend on fire cues like heat or smoke to germinate. Beyond physical remnants, soils carry ecological consequences of fires encoded in their chemistry. Soils remember the fires people set to. Charcoal layers often mark ancient hearths, cooking fires, and land clearing. In places like the Amazon, soils contain charcoal from fires thousands of years ago tied to early agriculture, mingling with rich dark earth known as terra preta. This human-made soil is both a natural and cultural memory, a living legacy of ancient land management. Fire's soil memory also influences ecological recovery. Charcoal acts like a sponge, retaining water and nutrients that might otherwise leach away. It provides surfaces for microbial colonization, supporting ecosystem regrowth. Soils enriched with charcoal are often more fertile than before. A paradoxical gift from destruction, however. Repeated intense burning can degrade soils by stripping organic matter, reducing moisture retention, and increasing erosion risk. Fires may create hydrophobic layers, heat-formed water-repelling compounds that cause rain to run off rather than soak in. These changes can persist for years, shaping how vegetation returns and soil stability lasts. Soils remember not just that a fire occurred, but its severity, influencing landscapes for generations. On a global scale, charcoal and ash form invaluable climate records. Researchers map the waxing and waning of fire activity over millennia, linking cycles to climate shifts, human changes in fire regimes, and ecosystem adaptations. The soil's blackened layers and pale bands become a planetary narrative intertwining flame, earth, and air. It is humbling to realize that beneath serene meadows or suburban backyards lie traces of ancient infernos. Tiny charcoal fragments are survivors of flame, reminders that seemingly stable landscapes have been shaped by fire again and again. Soil does not dramatize these events. Cliff holds their record patiently, waiting for those who know how to read the story. There is profound poetry in this resilience. Fire blazes brightly, then vanishes, but its traces endure in the ground-blackened carbon and pale ash woven into soil's fabric. Fire consumes, but cannot erase its own memory. The earth keeps it quietly, layers persisting long after flames die. Next time you walk on scorched earth, or stand near a dormant volcano, remember, beneath your feet lies a story already written. Soil carries fire's memory, not in words or photos, but in particles and chemistry. Every charcoal fleck is a fossilized spark, every ash layer a frozen plume of smoke. Together, they speak of destruction, renewal, and Earth's unbroken capacity to remember. Soil's memory is not only held in minerals or fossils, but thrives most powerfully in the living networks of microbes beneath the surface. Billions of bacteria, fungi, archaea, and other microscopic life forms inhabit every teaspoon of healthy soil, forming a bustling metropolis of activity that continuously records the history of the land. Microbial communities respond dynamically to changes and disturbances, adapting through generations and thereby holding echoes of past events such as fire, farming, floods, and pollution. When a wildfire sweeps a forest, for example, it might seem that the soil is sterilized, but many soil microbes survive as heat-resistant spores. These spores lie dormant until the environment clears, then awaken to decompose charred wood and help kickstart ecosystem recovery, effectively remembering fire by preparing for its recurrence. Similarly, Farm soils carry microbial legacies shaped by decades of plowing, planting, and fertilization. Some bacterial groups thrive in disturbed conditions. Others diminish, even after fields are abandoned and allowed to return to wild vegetation. These microbial fingerprints persist, influencing which plants return and how nutrients cycle. Thus, a forest that regrows on former farmland is microbiologically distinct from one that never experienced cultivation. Pollution also leaves enduring marks on soil microbes. Heavy metals, pesticides, and fertilizers alter microbial communities, sometimes leading to microbial evolution, such as bacteria developing resistance or fungi adapting to new chemical environments. These microbial changes can remain long after the pollutants themselves have faded and have been used by scientists to reconstruct histories of environmental stress. Microbial memory extends beyond scars to cooperation and continuity. Certain fungi called mycorrhizal fungi form extensive underground networks connecting plant roots, allowing the transfer of water, nutrients, and even distress signals. These wood-wide webs carry the ecological memory of forests, persisting through disturbances like logging or storms to help shape succeeding plant communities. In grasslands, microbial communities reflect histories of grazing. Specialized bacteria break down nitrogen-rich animal waste long after grazers have left the landscape, maintaining a microbial memory that primes the soil for future herbivore return. Likewise, cycles of flooding and drought imprint microbial fingerprints, with oxygen-loving microbes retreating in waterlogged conditions and anaerobic microbes thriving, producing gases like methane. Over time, this leaves a microbial record of how often and how intensely soils have experienced wet or dry extremes. There is evidence microbes can carry genetic memory through horizontal gene transfer, sharing genes across generations. It preserves adaptations to past challenges such as pollutants or pathogens. This natural genetic archive increases soil resilience by preparing microbial communities for recurring environmental stresses, effectively functioning as a memory system that guides the present, based on the past. The scale of this microbial archive is staggering. A single gram of healthy soil contains billions of bacterial cells and thousands of fungal species, encoding a genetic library far larger than the human genome. Sequencing soil DNA repeatedly uncovers countless unknown organisms, many of which may hold keys to ecosystem resilience and recovery. Researchers are exploring how microbial memory might help restore damaged environments by introducing microbes adapted to fire-prone landscapes or nitrogen fixation to depleted soils. Memory in this context is active, a tool for guiding ecological renewal rather than a passive record. Despite being among Earth's oldest life forms, microbes remain largely invisible to us. They do not fossilize but build living memories encoded in their communities and genetic patterns. Without microbial memory, soil would lose its vitality, continuity, and resilience. The microbial world beneath our feet quietly records every fire, plow, storm, and calm season. This invisible history offers comfort. While human memory fades and written records can be lost, soil microbes remember in the survival of spores, resilient genes, and fungal networks threading through darkness. Microbial memory is not ink on paper, but life itself. So, when a forest regrows after fire or a field bursts with wildflowers after abandonment, know that beneath the surface, armies of microbes have prepared the stage. They are the keepers of soil's living history, ensuring life's story continues, no matter how often interrupted. Fire has always been both a destroyer and a creator in natural landscapes, transforming forests and grasslands dramatically in mere hours. Yet, long after the flames subside, the soil beneath carries a persistent memory of fire through charcoal, ash, and altered chemistry. This chapter explores how soil records fire events and how these memories influence ecosystems over centuries and millennia. When vegetation burns, heat transforms plant material into charcoal fragments that resist decay. These dark flecks can remain buried in soil layers for thousands of years, acting as durable bookmarks in the Earth's diary. Charcoal forms when organic material is heated without enough oxygen to burn completely, resulting in carbonized lightweight particles that preserve evidence of past fires. Ash, by contrast, is the residue of fully combusted minerals like calcium and potassium. Though more vulnerable to erosion, When ash settles into soil, it changes. Chemistry sometimes making soil more alkaline or providing nutrient bursts that fuel rapid plant REGROWTH. Scientists analyze layers of charcoal and ash to reconstruct fire histories, estimating how often and how intensely fires occurred in particular landscapes. Some ecosystems, like grasslands, depend on frequent burns to maintain open fields, evidenced by regular charcoal pulses in soils. Forest soils might show fewer but more intense fires. These soil fire records also reveal how ecosystems adapted to fire regimes over time. Volcanic eruptions leave distinct ash layers in soils, rich with unique minerals serving as precise time markers. For example, Mount Mazama's eruption about 7,600 years ago scattered ash widely across North America, leaving a soil trace still recognizable today. These ash layers function as timestamps connecting soil changes to specific historic events. Fire also alters soil chemistry. Phosphorus and potassium often increase after intense burns, acting like natural fertilizers that explain vigorous post-fire plant growth. Some plant seeds even rely on heat or smoke to break dormancy, showing how fire memory is encoded in ecosystems. Human history is inscribed in these fire memories too. Ancient hearths, land clearing, and cooking fires left charcoal traces in soils long before written records existed. In the Amazon, for instance, dark earths called terra preta contained charcoal from controlled fires thousands of years ago, representing rich, enduring soils engineered by ancient peoples. Charcoal's porous nature helps soils retain water and nutrients, supporting microbial colonization and ecosystem recovery. Fire remnants thus serve both as historical records and as active participants in rebuilding landscapes. However, repeated intense fires can harm soil by depleting organic matter and creating water-repelling layers that hinder moisture absorption, illustrating that fire memories can shape landscapes both positively and negatively. Globally, charcoal and ash records help scientists map shifts in fire frequency linked to climate change and human activity. They reveal how fire regimes waxed and waned with temperature and precipitation patterns, and how human land management altered natural fire cycles. Beneath quiet fields or backyards may lie evidence of infernos long past, demonstrating the Earth's enduring ability to remember fire. This chapter highlights the poetic resilience of soil's fire memory. Fire's blaze is brief, but its traces are woven deeply into soil layers for centuries or millennia. The soil patiently preserves these chapters of destruction and renewal, silently testifying to fire's vital role in shaping the world. Pollen grains are tiny, microscopic dust produced by plants to reproduce, often seen drifting in vast clouds during spring. Although pollen seems ephemerally swept away by wind or rain, many grains are incredibly durable, settling into soils, lakes, and sediments where they can survive for tens of thousands of years. Their tough outer walls, made of resist decay and chemical attack, making pollen one of nature's most enduring materials. Each plant species produces pollen with distinct shapes and surface features like spines, ridges, or pores, enabling scientists to identify species precisely under microscopes. By extracting sediment cores from lakes or soils, researchers can read pollen layers as chronological records of past vegetation, climate changes, and human activity. For example, pollen records reveal Ice Age forests dominated by spruce and pine, later replaced by oak and hazel during warmer periods, followed by grasses and cereals reflecting farming and deforestation. Pollen analysis has revolutionized our understanding of how ecosystems evolved, how climate shifted, and how humans reshaped landscapes across millennia. Beyond Europe, pollen in Central America tracks the rise and fall of the Maya civilization through forest clearance and regrowth cycles. In the Sahara, pollen preserved in buried soils reveals a once green landscape that now lies as desert. Pollen's resilience also aids forensic investigations, where distinctive pollen profiles can link soil samples or objects to specific locations. This interplay of fleeting airborne grains and enduring soil records links the brief flowering of plants to the long memory of the earth. Pollen is nature's ink and soil its page together, writing one of Earth's most durable chronicles. Every season, billions of grains are released, many destined to become part of a permanent archive. This archive tells stories not only of environmental change, but also of continuity, showing how plants persist through ice ages, heat, abundance, and scarcity. In this way, pollen connects the ephemeral present with eternal histories, whispering the existence of lost forests and ancient landscapes to those who know how to listen. In the quiet earth beneath you lies a secret library, where life's stories are written not in ink or stone, but in delicate strands of a whispering code. This code, called DNA, carries the instructions that shape every living being. From teeming microbes to towering trees, from ancient mammoths to the grass beneath your toes. Tonight, as you settle down and your mind begins to drift, we enter this hidden world, listening to the gentle pulse of Earth's enduring memory, a record held in the molecules that rest silently beneath your feet. Thousands of tiny fragments, like invisible letters scrawled in a vast and ancient manuscript, wait patiently in the soil. DNA, short for deoxyribonucleic acid, is the blueprint of life, a spiral ladder of instructions coiled inside every cell. Normally, when a creature dies, this fragile thread unravels quickly, broken down by sunlight, water, and bustling life. Yet, sometimes, the soil cradles these fragments gently, locking them away in cool, dark, and quiet places, shielded by tiny mineral surfaces or tucked deep within hidden pores. In these small, sacred spaces, the code survives far longer than you might imagine, sometimes for thousands or even tens of thousands of years. Imagine soil as a vast, molecular memory bank. Unlike fossils carved in stone, these strands do not need bones or shells. They come from all manner of quiet traces: a paw print pressed into mud, a tuft of hair caught in the earth, or leaves that have fallen and crumbled to dust. Through careful science, researchers can gently unravel this code, like piecing together a shredded letter, restoring voices of long-gone creatures and lost landscapes. From the frozen soils of Siberia, scientists have read the secret stories of woolly mammoths and ancient bison, creatures that once roamed across ice-covered plains, now silent under layers of earth. But the soil's memory stretches far beyond giants of the past. Seeds of long-vanished grasslands and forests whisper their stories through fragments of chloroplast DNA, illuminating how plants have shifted with the rhythm of warming and cooling over centuries. Even the tiniest soil microbes, invisible architects of life, leave their genetic signatures, telling us how life below ground has changed and adapted through time's endless dance. You and I, too, are part of this hidden narrative. At ancient campsites and caves, soil bears the faint imprint of our ancestors, not just their footprints, but traces of their animals, crops, and the daily lives long since passed away. It is as if the ground itself keeps a quiet diary of human history, preserving moments no stone or pottery shard could fully hold. Unlocking these mysteries requires gentle hands and delicate tools. Scientists extract small soil samples and coax out the fragile DNA within, amplifying the tiny fragments through a process called polymerase chain reaction, a way to multiply minute whispers until they can be heard clearly. Then, like skilled translators, machines read the genetic code, matching it against a vast library of known life to reveal who once lived or grew here. To protect these precious stories, laboratories keep their spaces scrupulously clean, ensuring that the voices of ancient life are not lost amid the noise of modern-day dust. This molecular memory isn't only a window to the past, it is a lantern for the present. Conservationists listen to the soil's gentle hum, using DNA fragments to detect rare or shy species before they appear on the forest path, helping protect them quietly and effectively. Each particle of soil becomes a messenger, carrying news from hidden corners of the earth where life silently thrives and struggles. There is a quiet poetry in knowing that beneath your feet lie the echoes of whole worlds once alive. The mammoth, wandering a snow-dusted steppe, had no idea that its cells scattered across frozen earth would one day tell its tale to human listeners. A flower's petals dropping to the soil never dreamed that their DNA would reveal secrets of ancient climates warmer than today. Soil does not forget, it only waits patiently for someone curious and kind enough to listen. In this grand archive, time stretches like an endless thread, far beyond the brief spans that your own memory can hold. Written history may span centuries, and your family's stories perhaps only decades. But the soil remembers deep epochs, ice ages when glaciers gripped the land, eras when creatures and forests now vanished thrived beneath a different sky. To hold a vial of ancient soil, then, is to cradle a census of lost worlds. Yet this memory is fragile and precious, never perfect. DNA slowly fades, and much is lost to decay, but enough remains to sketch the outlines of ecosystems that would otherwise be forgotten, reminding us that the life around us is part of a sequence larger and longer than any single moment. Soil is no longer just earth and dust. It is a living library, a storage device of astonishing complexity, from which stories of species, climates, and cultures emerge like gentle breaths from the past. As your body relaxes and your thoughts begin to settle, imagine the soil beneath you holding the blueprints of every seed, leaf, and creature that has ever touched this place. It hums quietly with resilience, weaving together life and memory in a tapestry invisible to the eye but rich beyond measure. And as you drift toward sleep, rest in the quiet comfort of this knowledge. Beneath your feet is a patient companion, a living archive that will remember your footsteps long after you are gone. Who knows what stories the soil will whisper next? Perhaps one day, long in the future, someone will uncover a new secret in the earth, a gentle echo waiting to be heard.